Let's go through LeetCode 1585. Check if string is transformable from string sort operations. So there is a source string and a target string. So we can choose any part in the source string in the any substrings in the source string, for example, the source string, and choose, for example, some kind of subarrays and sort this kind of subarray. And by doing this kind of sort operation, it is asking whether it is transformable. We can get the source to transform to target. For example, the example one, right? So let's say that is 84532 and 34582, right? So so we can do actually we don't need to follow its order, right? So what we do is that we look at the first element on the target, and we can sort, for example, from 3 to 8, right? So it is just ask true and false. So it will be 3, 4, 5, 8, right? So the target is this is the source, it becomes 3, 4, 5, 8, and the target is 3, 4, 8, 5, 2, right? So let's see these three we can get rid of that. And the 4, let's look at target. The second character is 4, right? And then this already been sorted, so that we can get rid of this. And then we have 8, right? So our source 8 we want to put on the front, right? So we can choose 5 and 8 to sort as a 5, 8, 2, right? So we get rid of 8 and 5, 2, and the 2, 2, right? So so this return true. So this is the way to do like a bubble sorting. Bubble sorting, but the thing is that to do bubble sorting, we compare one by one. It will be O(n) square time complexity. Um, so we should do something for this kind of time range. It will be out of time, right? So we should do some better approaches. So if we have source, right, we know if we sort some part of this kind of substrings. So for sort, what we do is that we are going to move the small character or say lexically smaller character to the left and move the lexically greater character to the right, right? So the things that if, for example, there is um, C, a character C here, right? And on its left, there is A, right? Of course, we cannot move. This is just a number, right? For example, there is number 4 here. There is a number 1 here. It's impossible that we, by doing sort, we put 4 on the left of 1, right? So, um, so the thing is that we this question is just asking whether it is possible, and for example, if we do bubble sorting, right? We do character by character. For example, there is 3, right? Our approach is that we look at this 3, and then we get rid of this 3, and then there is 4, right? Get rid of this 4, and 8, right? So 8. Uh, so there is 3 and 4 being left. And on its left, there is no smaller number, right? So we can also still get rid of 8. In 5, if we get rid of, you'll see this kind of 4, right? 4 already been get rid of. On its left, there is no smaller number of 5 on smaller to 5 on its left already. So we can still get rid of 5, right? So and also the 2, right? But if we go through the example 2, right? So what happened is that we this is still true, right? But this one, let's say if we get rid of 1, 2, 1, 2, but now we go to the character 4, right? But on its source, you see there is a number 3 on its left. So in any way, we are not able to do reverse 3 and 4 because we didn't get rid of the 3, right? So if we know this approach is that by sorting, we can get a smaller number on its left, on its right to its left positions, and a right number on its a great number on its to the right, right? So if we know this, we should have some better approaches. That is, if there is a smaller number on the left and a larger number on the right, it's impossible that we, by sort, we get a smaller number to the right, right? It's impossible. So we just trying to go through if we have this kind of contradict, then return false. If we can get rid of all of the characters in T, right? We just return true. So what we need is that instead of checking for every character whether on its left, we need some kind of simulate this kind of approaches, right? So what we do is that we're going to create for every character, every number, create a queue to store to put its um, index, right? As we have a queue array to put this kind of indexes. We call index plus new queue. So it is 10, right? So we'll say arrays field set all index. It goes to new array. So in the source, we trying to put those kind of characters. So what we do is that let's put change this one to s array equals s which array. So what we do is that let's put those kind of index. So we have index s array I minus 0 should offer this index. So then we trying to just look at those kind of characters in T, character by character, right? So what we do is that in T, right, we look at those kind of characters. If we find, for example, 0, right, and there is a 0 cube, index 0 cube, we just get if there is indexes, right? So we just get rid of this and go to the next position in T. And for example, there is 4, right? And 4, if we also look at the fourth index cube, so we also get rid of the first index is in this queue. Before we check 4, right? We need to check what? We need to check those kind of queues from 0 to 3, right? So if there is some kind of indexes in this kind of index array, they 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 are they have some kind of index is smaller than this fourth index. That means we have some in the source there is a smaller character on its left, right? So in this case, in any case by sorting we cannot get a S to target. So what we do is that for every character in T to array, we are going to have, let's have int d equals c minus 0, right? And we will say if in the index d, this one is empty, right? That means um, we cannot find a character in C, a character in source, right? So we just return false. Otherwise, what we do is that we need to do for int I equals 0, I smaller than d, I plus plus. And we are going to have if this kind of queue is not empty, right? It's not empty. If it is empty, we don't need to check, right? If this is not empty and this kind of index I of peak, if this one peak is smaller than index d dot peak, right? That means we have a smaller number, have a smaller index, then we just return false. And after we go through all of these characters, right? And we will also need to pull, right? Index D to pull for this kind of index out. Then we just return true. Doing like this, we have ON time complexity and ON space complexity, right? Because that is Q linear. The Python code is similar. Let's also write a Python code. So let's put a deck from collections import deck. And we are going to have an index and equals deck for this one in range 10. Then what I would do is that for I it's an enumerator as, and we're going to have index let's convert this one as this character as int append, right? Then we just iterate those characters in T for stay in T. Okay, so D equals int C, right? Then what we do is that if we didn't find any this kind of queue is already empty, right? That means the source will not match the target. Just return false. Then what do we do is that for I in range D, right? Then if index I is not empty, in the index I 0 is smaller than index D0. That means there is some kind of smaller number and a smaller index on the flag, which is returned false, right? So after we match one character, we need to put just pull out or pop left those kind of index D out, right? Because we already match, just use pop left. Don't forget this one. Otherwise, because we already for it doesn't mean that on big number on the left doesn't have cannot have left a smaller number. But the thing is that when we go to here, if there is some smaller number, we didn't match on the source that are written false, right? So return true, otherwise return true.